We will talk about k-fold cross-validation in this video. To understand cross-validation, we must know what train, validation, and test sets are. For each machine learning model, the train, validation, and test sets are distinct portions of the data. Train set is used to train the machine learning model. The model learns from the train set by analyzing the patterns and relationships between features and target values. Validation set is used to evaluate the performance of a machine learning model during training. It helps in tuning the hyperparameters of the model, which are used to optimize the model's performance. Test set is used to assess the final performance of the trained and the fine-tuned model. It helps in estimating the generalization capabilities of the model. It must be noted that we never tune the model using the test set. To understand why we need cross-validation in the first place, we need to understand the train-test-split method that we use to split the data into train and test sets before training a machine learning model. The train-test-split works by randomly shuffling the available data and then splitting it into train and test sets. Depending on the value of the random state parameter in the train and test split method, the shuffle will also change. This will result in different data points in train and test sets for different values of random state, and thus leading to varying model performance. Let's understand k-fold cross-validation. Suppose we are building a binary classification model where we denote train data by green color and test data by gray color. K-fold cross-validation works by shuffling the data and then dividing the data into k equal parts, also known as k-folds. Suppose we choose the value of k to be 5, which means we divide the data into 5 equal parts after shuffling it. Now for each fold, we create a model with one fold as test data and rest folds as trained data. We calculate the model performance for each model and then average out the model performances. Let us suppose accuracy denotes our model performance for our binary classification model. For model 1, we choose fold 1 to be test data and rest as the trained data, and we get the accuracy as 90%. Similarly for model 2, fold 2 is the test data and rest as the trained data, and we get 95% as the accuracy. And similarly, till model 5 we get the accuracies for each model. Now we have selected all the folds as test folds in the 5 models. Now we will calculate the average accuracy, which comes out to be 79%. Therefore, cross-validation has helped us to get less biased or less optimistic estimate of the model's performance. If we would have created only one model whose accuracy was 95%, we would have incorrectly overestimated the model's overall performance. That's why we use cross-validation. That's it for this video.